BKW Physics. I'm Mr. McConley. We're going to do a classic experiment today where we have two metal spheres. And these two metal spheres, one has a hole drilled through it and the other is solid. But remember, mass doesn't make any difference when you're dropping two things. They will accelerate due to gravity and they will hit the ground at the same time. So don't be concerned that the one has a hole in it. That doesn't affect anything. What we're doing here is one will be launched, but not, well, some people think it's going to be fired like a missile. No, it's just going to be like, it's just going to get launched, like knocked off the edge. And the other will be just simply dropped. But the way this device works, it's on one lever here, so it's timed so that both things happen at the identical time. So the one that's getting launched and the one that's getting dropped are at identical times. So the first thing I do is make sure everything's level with my submarine level here. Level. I put the one on the end. I put the other one right there. And then what we're going to have to watch carefully for, and the way to really do this is don't try to follow the ball down with your eye. Just try to generally stare in the direction of the experiment, and you should be able to see both balls and see if they hit at the same time. Okay? So here we go. Okay. Pretty close? Can't stop these things when they start going. So is that pretty close?
Yeah.
It sounded close.
Yes.
It sounded pretty close. We'll do it one more time. And then what I want you to do is really try to think, why is that possible? How can these be hitting at the same time? So here we go again. Ready? And fire. That was good. I let it bounce twice. You can hear it hit at the same time 2 times in a row. So, how is it that a ball that's being dropped straight down can be ending up on the table at the same time this other ball is going all this distance and coming down like that? How is that possible? What are your thoughts?
As well as accelerating at the same time.
Okay, gravity is affecting both of them.
Yeah.
True, true. Why doesn't the fact that this one's traveling further, wouldn't you say? If you were to, have some sort of distance measurer, like if we played it and then we drew a line on the screen and we measured the line, that's traveling further. This one has a straight line, boop, right to the ground. This is traveling a long distance. So what must be true about the one that's traveling further?
Just a little faster.
It's got to be going faster. And what did you say about horizontal? It does have a horizontal velocity, but it's constant. Okay, so it's going forward, same speed, it's going this way, the same speed the whole time, but that's not even the issue, because it doesn't matter how fast it's going forward. All it matters is how much it's speeding up in the downward direction, and both of them are equally affected by gravity. So if you were to play this back, say you watch this on the computer later, the video we just made, you play it back and you watch after a certain amount of time, say this ball is right here at this height, where is this one going to be? It is going to be at the exact same height, only it's going to be out here. Okay? Because they will both go down the same amount in the same amount of time. So for today, physics.